little instruction about how to do your lab report today. So I should have given you a picture that I took of your gel or somebody's gel that worked well. And you are going to paste that picture in here. Okay, so you're just going to tape it into here. Okay, and you're going to read all the directions, but I'm going to kind of show you what the gels should look like. So let me switch over to a picture just to kind of talk about this. Okay, here's a couple of sample gels. So I don't know what lanes you might have had, A, B, or C, or D, E, or F. But so for you, this could have been A, B, C, or if you did D, E, F, which were the same things. You know what you put in each lane of the gel. So this is a picture of the gel. These two are the same pictures. I'll just kind of show you. You're going to get sort of this. Wait, let me change the blue to... Okay. So you're going to get this. So let's assume, I don't know if you can see there are wells here. So these are the wells that I just outlined in yellow, your 6 lanes. And you might have done these in a different order, but whatever lane you put A or D in is lambda DNA that was uncut. Ignore this little bit if you have something right there coming out of the lane and other things. You should have one band in that lane because you didn't cut it. So it's just one big piece of lambda DNA. In this lane that you cut with Echo R1 or that was already cut, that would be your B or E, depending on which sample you got. This is lambda DNA cut with Echo R1. And in that lane, whatever lane that is for you, there should be 5 bands. Sometimes this 5th band is very faint and doesn't show up, but you can see here, there's 1, 2, 3, 4, and then there's a faint 5th band there here. And you'll notice the bands sometimes look kind of like staples. Just kind of ignore that part there. That's just because we ran it too fast in the gel. Sometimes it smears on the sides. Okay. Then in this lane, which would have either been lane C or F for you, this is lambda DNA cut with Hindi 3 that you loaded here. And in this lane, there should be 7 bands. 1, 2, 3. There's a 4th band that is very faint, but look carefully. 4, 5, 6, and then the 7th band way down here is also very small. So there's 1, 2, 3, there's a 4, 5, 6, 7. So if your picture doesn't have, or some of these faint ones don't show up, go ahead and draw them in based on this. And yours, like I said again, yours might have been in a different order, but you know what you put in each lane. So label your picture with what was in that lane, lambda uncut, lambda cut with Echo R1, etc. So label on your picture, on your lab report, you're going to tape this picture in or whatever picture you got of your gel and label what was in each lane, just like I did here in pink. Then what you're going to do is this, whatever lane was the lambda DNA cut with Hindi 3, so for us, that's this, the one that has the 7 bands is going to be the marker lane, which I already wrote there. So in the lab report, I'm going to switch over to that. This, I'm giving you the sizes of all 7 of the pieces of DNA in these 7 bands. So you are going to have to measure with your ruler right on your picture. Take your ruler and start at the beginning of the, or the end of the band here, and measure to where you think, just sort of like estimate sort of the middle of the band there. And measure that in centimeters. And you're going to do that for each band. Measure from the band or the well to band 2. Measure from the well to band 3 and 4 and so on. Okay, so you're going to measure with your ruler on the piece of paper I gave you the distance that all of these went in the marker lane. I'm going to switch over to the lab and then show you where that information goes. And that's going to be the lane lambda DNA cut with Hindi 3 that you are given in the lab. So here's your lab. That picture that I just showed you, you will paste that in here. Don't forget to label all the things I tell you to label. And it tells you right here, measure the distance traveled by each of the standard DNA fragments. That's going to be the ones cut with Hindi 3. Okay. And then gives you the sizes in base pairs of those here. So there's 7 bands. I just numbered band 1 was 2, 3, 4, 5, 6, 7. So this is the marker lane. These are the distances that you're going to put in here. So you're going to measure, you know, however many centimeters it was to the first band and the second, whatever. So your distances in centimeters that you measure on, you know, this picture that I just showed you, you're going to fill those in. Remember, the band closest to the well, you know, this should have the smallest distance, and then these should have larger distances or the smaller pieces. So now you have the distance migrated and the known sizes of all the bands in that lane, which we're going to call the marker lane. So I kind of wrote some stuff here just in case. So on the gel pick, you're going to measure with a ruler the distance in centimeters, like I just showed you. And then you're going to write those distances here. Then what you're going to do is plot this information on your graph paper. So you should have, I forget what page it's on, but if you scroll through, you should have a piece of log graph paper. And you're going to, I drew it here in orange, you're going to create a line of best fit after you plot the points for this data here. Okay, so let me just scroll ahead to like the graph. Right, here we go. I forget what page your graph's on. So this is log graph paper. So you'll notice on the x-axis, it says like migration distance. So this will probably be centimeters for you guys. I mean, you could do millimeters, I guess, but I think all the things say centimeters, so just do centimeters. So you'll have to label like whatever, 1 centimeter, 2 centimeter, 3, 4, whatever your scale is there. Okay, that's the distance migrated in the gel that you measured with a ruler. That goes on the x-axis. The y-axis is the size of the DNA fragments. So you need to write that because they just wrote base pairs. They gave you the unit, but you need to write this. It's the size of the DNA fragments. The unit is in base pairs. But notice if you've never used log graph paper before, it's a little different. So this first round here in the log graph paper, these are hundreds. So it's 100, 200 base pairs, 300. So each line goes up by 100. But notice the spacing's different. That's just because the relationship is not truly linear, but you don't need to understand why. Just this gives us a better kind of scale to estimate. But notice this goes up by hundreds. So anything that's from 100 to 1,000, you will plot here. Then the next log, now notice this goes up by thousands. So it's 1,000, each line is 1,000. So it's a log 10 jump here, whatever you want to say. And then this next phase in the paper goes up by 10,000. So this is 10,000, 20,000, 30,000. So depending on what size your things are, you'll plot. So you had 7 bands, and don't forget the title, which should have those 3 things in it. You're going to plot your marker lane here, okay? And that's the very first one. That's the one that's lambda DNA cut with Hindi 3. And there's 7 bands. So you should have 7 points. I don't know what they are. I'm just going to draw 7. 1, 2, 3, 4, 5. I made that up. Okay. But you're going to actually plot those based on the distance and the size given to you and create a line of best fit. This isn't with a ruler. I'm just doing a rough one. Then we are going to use this to estimate the sizes of the bands in the other 2 lanes. Okay. So it gives you this directions here too. If you want to scroll back here, it explains the semi-log graph paper and how to label whatever. And there's my line of best fit. And then you are going to use your graph to estimate the sizes in the other lanes. Okay, so you're going to measure the distance, read up to where it hits your line, read over to estimate the size. This doesn't have the right sizes. Okay, so I'd like you to actually kind of show me in red or in some color on your graph on your real graph, show me draw a line of best fit. And then I'd like to see kind of these little lines showing me how you estimate the others. So here's the other two lanes, okay? So the distance migrated by when it was cut with Echo R1, you're going to measure these on your picture of the gel. So let me go to the picture of the gel. Okay, back to the picture of the gel. So whatever lane had the 7 bands in, that's the one you already measured the distance and plotted these because I gave you the sizes of these bands. That's you plotted. Now what you want to do is estimate the sizes of the bands in this lane and the 1 band in that lane. So once again, you're going to measure, this time you don't know the size, but you're going to measure the distance migrated from the end of the well to that band and so on. You'll do that for all 5. So measure that distance in centimeters, and you're going to put that in right here, okay? So there are over 5 bands in that lane. So you measure the distance of those measured, and then this, you get this number from your graph by going, okay, well, I'm just going to give you an example. Let's say it migrated 2 centimeters, the first band. So you're going to go over here to your graph, go to 2 centimeters, go up till it hits your line of best fit, go over, and whatever that size is, you're going to write right here. That's going to be the size in base pairs. Okay, so you're going to do that for all 5 bands in that lane and estimate the size. I want to see that it came from your graph. And then the last lane the uncut lane only had 1 band in it. So that's why this is blacked out. You're not writing anything in here. But the other lane, this one, okay, the DNA that was uncut, because we're ignoring that, only had 1 band. So you're, once again, going to measure from the well to that band and go back, put that in here. You'll put that in right here, whatever that distance is. Okay, get a color, right? And then you're going to look that up on your graph and write that size right there. Okay, so the 1 lane you're using to create your line of best fit, the one with 7 bands, and then the other 2 lanes you measure on your picture and estimate the size. Once you've estimated the size, everybody every year forgets to do this. It tells you, look up here, there's directions. Just read, please read. It says label what was in each lane and label the sizes of each band in base pairs. So once, you'll have your picture here that I gave you with your whatever. You're going to label what was in each lane, lambda cut with whatever, lambda cut with whatever. And then, I'm just making up bands here. You're going to label these with sizes like 23,000 base pairs. And you can kind of do it here on the side, whatever. Although the big one wouldn't go there. This is like, this one was 750 base pairs. This band was. So you can write on here, you're going to label the sizes of all those. And I have Sharpies out or some kind of marker that you can write on that picture. People lose credit every year because they don't, after they calculate the sizes of each band in each lane, go back to your picture and write it on there, okay? So that is what you are doing. Then there's just questions you can do, so I don't think you need help with that. But these are pretty easy. Skip this number 4. It just takes too long. It's just like a big puzzle, and I'm trying to go fast here. So you really only have to answer like 3 questions and then some multiple choice practice. So for this one, a lot of people get this one wrong. Okay, it's giving you this band right here. It says circled in red below. I didn't do it in color. So that band right there. And it's showing you like this is a gel, here are the wells, and here's a ruler. And so if you see, it went about 22, I guess we're doing millimeters here. So let's assume this is in millimeters. Okay. So if that band that we circled, if I measured that it went 22 millimeters, you're going to look up that here, 22 millimeters up and over, and estimate the size there. That's what you're writing. A lot of people get this wrong. And the rest I think are pretty easy. So that's it.